Today we're going to talk about the special parallelogram. So yesterday we talked about parallelograms in general. Today we're going to focus on rhombus, rectangles, and squares. So at this point what I'd like you to do is take one of your pieces of patty paper and your ruler. If you lay your ruler down, you can trace on each side, make parallel lines. Okay, so you're going to trace parallel lines, on your, there you go. Trace parallel lines on each side of your ruler. Turn your ruler then and trace more parallel lines. So now, because we're doing the equidistance from the ruler, all four of these sides are going to be congruent. Okay, so you've created your rhombus. So you're just going to focus on the rhombus itself. What I want you to do is I want you to look at, the first time, look at the diagonals. I want you to draw on your diagonals, measure them, look at the angles involved, check out the angles in the corners, I guess, of the rhombus. So measure all of those. Okay, so we're going to give you about 2 or 3 minutes here. When everyone's done, then we'll start the video again and we'll fill in those blanks together. Okay, so you should have had enough time now. So let's fill in the blanks. It says the diagonals of a rhombus are perpendicular and they bisect each other. Okay, so in our rhombus, when you have your diagonals, okay, they are perpendicular, so you have a right angle here, and they bisect each other. So here's a rough sketch of what that might look like. Okay, so the diagonals are not congruent, but they do bisect each other. The other thing you should have figured out is that the diagonals of a rhombus are going to bisect the angles. So for instance, these two angles are congruent. And because opposite angles are congruent, we talked about that yesterday with parallelograms, actually all 4 of these angles here are going to be congruent. Same thing is true along the other diagonal. So the diagonals of a rhombus bisect the angles of the rhombus. Okay, so make sure you have that written down. Okay, so if we take those ideas, we're going to take those ideas and we're going to look at this problem here. So it says use rhombus LM and P and the given information to find each value. So I want to find y if the measure of angle 1 is y squared minus 54. And now because it's a rhombus, we should know that we have right angles. Okay, so that means that y squared minus 54 should be equal to 90. I can add 54 to both sides, so I get 144. Take the square root of both sides. So y is going to be equal to 12. Now, it would be plus or minus 12, technically, right? However, in geometry, we typically only look at the positive root. Okay, so y is equal to 12. The next problem that says, find the measure of angle PNL. So PNL, I'm looking for this angle right here. If MLP, so this whole large angle here is 64. Now remember, if this is a rhombus, then the diagonals are bisecting those angles. So really, each of these smaller angles here at L are going to be 32. And each of these here are going to be 32. Another way to think about this is, keep in mind, this triangle right here is really isosceles because you have a rhombus, which means all 4 sides are congruent. So that triangle up there is isosceles. So that makes these 32-degree angles here and here, those are base angles of that isosceles triangle. So we know that the measure of angle PNL is equal to 32 degrees. Okay, next we're going to look at properties of rectangles. So on your notes to the right of this slide, you have some graph paper. So go ahead and use your ruler. I want you to create a rectangle, so construct a rectangle there. Then go ahead and measure your sides, measure your angles, and then try to fill in the blanks here. So we're going to pause again. So we're going to pause the notes. You guys are going to do your thing for a couple of minutes. When you guys are ready, we'll go ahead and start the notes again. Okay, so the diagonals of a rectangle are congruent. They are the exact same length and they bisect each other. Okay, so they are congruent and they bisect each other. So again, so think about this. If they bisect each other, we know, for instance, those two pieces have to be congruent. Okay, but keep in mind, if the diagonals are congruent, actually all 4 of those segments would be the exact same length. So I know, for instance, if this is 10, this part has to be 10, this is 10, and this is 10. All right, so we have 2 examples here. I'm going to give you a couple minutes. I just want you to look through these 2 examples. We're going to pause the video again in a second. So look through both of those. And the first one you're solving for x, the second one you're solving for x and y. So keep in mind these are both rectangles. So go ahead and pause, and when you're ready, we'll start the video again. All right, so let's take a look at the top one. It says quadrilateral RSTU is a rectangle. We know RV is, 3x plus 2, and SU, so this whole piece here, is 7x minus 4. All right, so we learned earlier that the diagonals have to be congruent. And we also know they bisect each other. So if RV is 3x plus 2, VT is also 3x plus 2. So I can say that 3x plus 2, 2 of them, would be equivalent to the other diagonal SU, which is 7x minus 4. So let's go ahead and do the algebra here. We need to distribute that 2. So we end up with 6x plus 4 equals 7x minus 4. Subtract 6x from both sides. I have 4 equals x minus 4. Add 4, you should have x equals 8. All right, next, the second one down here. It says quadrilateral LMNP is a rectangle. We want to solve for x and y. Okay, so we need to remember in a rectangle we have right angles. So angle L there, that large angle L, angle MLP. So angle MLP right here. This is actually a 90-degree angle. So I know that 5x plus 8 plus 3x plus 2 has to equal 90 degrees. Okay, so we're ready to combine our like terms. We have 8x plus 10 equals 90. Subtract 10 from both sides, so I have 8x equals 80. So that gives me x equals 10. All right, so we have x. Now we need to think about y. So because we have a rectangle, it's truly a parallelogram, right? So that means those 2 lines are parallel, and then LN here is a transversal. Okay, so there's my transversal. So if I think about looking at these parallel lines and this transversal, that tells me then that these 2 angles have to be congruent because they are alternate interior angles. Okay, so now we know x is 10. I can plug it back in here. So I know that this angle has to be 3 times 10 plus 2, or 32 degrees. That means this angle here must also be 32 degrees. So 6y plus 2 has to equal 32 degrees. So subtract 2, we get 6y equals 30. Divided by 6, we have y equals 5. Okay, I'm not actually going to have you do this, this investigation, but keep in mind a square is both a rhombus and a rectangle. Okay, think about that family tree. I have it drawn on the next slide there. Think about that family tree in that if you have a square is a rectangle and a square is a rhombus. Remember how we did that always, sometimes, never? So think about all those properties we just learned about a rhombus and a rectangle. Because a square is a rhombus and a rectangle, it has to have those properties. So the diagonals of a square are congruent, they are perpendicular, and they bisect each other. Okay, so it's everything. It's the congruent from the rectangle. It's the perpendicular from the rhombus. And then they bisect each other. That's true with all parallelograms. That's a parallelogram trait. Okay, here's the family tree that I talked about. So keep in mind, we're focusing specifically in this area today, right? So yesterday we learned about parallelograms. A rhombus is a parallelogram. A rectangle is a parallelogram. A square is a parallelogram, right? So all three of those shapes have to have all the parallelogram properties. They actually have more than that because they're very specific. So what I want you to do, on the bottom right-hand corner of your notes, I have a table. I'm going to flip to that now. Okay, there we go. This table. What I want you to go through, we're going to pause the video again in a second. I want you to place check marks when things are true. So for instance, all sides are congruent. Is that true for a parallelogram? Is it true for a rhombus? Is it true for a rectangle? Is it true for a square? Okay, so I know, since you're all such good math students, you just marked rhombus and square. Okay, so I want you to go through and think about that. If you want to do it by shape, you can do it by shape, or you can do it by line. Okay, once we're going to give you a couple minutes to think through that, and then we'll go through the answers. Okay, go ahead and check your answers. This is what you should have, so please make sure your table matches my table up here. Okay, and you can pause the video if you need to, if you need more time. But you keep this table, okay? You got to kind of commit it to memory a little bit. You need to know these properties. You have a worksheet for homework. It's just focusing on parallelograms, rhombus, rectangles, and squares. Okay, all of it is just solving for missing angles and side lengths. Okay, we'll go over that first thing on Monday.